Dear students, welcome to today's class. In the yesterday's class, I have explained the differentiability of a function at x is equal to a. That means a function is differentiable at x is equal to a means at x is equal to a there exists a tangent. Okay now at what situation a function is not differentiable? Okay, let us see that. So, reasons for non-differentiability of a function at x is equal to a. Then when what are the situations it is not differentiable? Let us see that. The first situation you see here, it is a function, it is defined as y is equal to f of x curve. It is a y is equal to f of x. At x is equal to a, it is not continuous. See here, there is a break. There is a break. At x is equal to a, the curve is break. Therefore, f is discontinuous at a, therefore non-differentiable. It cannot differentiate. That means at x is equal to a, you cannot draw a tangent. How can you draw the tangent? There is a breakage there, no? When there is a breakage, how can you draw the tangent? Understand that? So, what is the one of the reason for non-differentiability is what? If there is any discontinuity is there, then at that situation also the function is not differentiable. Already I have given, we have explained one theorem that if it is a continuous, then only we should talk of differentiability. Okay now, right. Another situation is there. Here, this left hand side derivative and the right hand side derivative both exist, but they are not equal. Just like modulus function, Here left hand side derivative exists, that is a -1, right hand side derivative exists, that is +1. Both are not equal. At that situation, there will be a sharp edge will be there. There will be a sharp edge. So, wherever sharp edge is there, then that point, even though it is continuous, but at that point the function is not differentiable. That means what? We cannot draw the tangent here. We cannot draw a tangent any at the sharp edges. Okay now, already I told that this differentiability gives the, it is also helpful as to define the smoothness of a curve, That means if it is whether smoothness or not there, that means, so at the situation we can draw a tangent here. So if it is a sharp edges are there in a curve, at the sharp edges are there, at the sharp edging points, even though the function is continuous, you cannot draw the tangent at the sharp edges. So this is also one of the reason for non-differentiability of a function. Right. Let us see another situation. Here, either or both f left hand side derivative and right hand side derivatives are not finite. That means, if left hand side derivative exists, then right hand side derivative does not exist. Or if right hand side derivative does not exist and the left hand side derivative exists, or both does not exist. Okay now, at that situation also the function is not differentiable. At that situation, we will get a vertical tangent. We call it as a vertical tangent. Even though it intersects the curve at x is equal to a, we call it as a vertical tangent. So that at that situation also, the function is not differentiable. So when we get the vertical tangent, so left hand side derivative, right hand side derivative, either of or both does not have any finite value. So these are the three situations where a function gets not differentiable. Okay now what we are going to see is sir, you are saying always, now so far what we are seeing, we are testing the differentiability of a function at x is equal to a. That means at an x is equal to a, whether we will get a tangent or not, we are going to see. Now we are going to see the derivative or differentiability of a function in an interval. Now we are going to see the differentiability of a function in an interval. in an interval, closed interval a to b. Okay, na? So let us see that. Welcome to the concept that differentiability of a function in closed interval a to b. Let us define a function f from closed interval a to set of real numbers. Okay, now that means, so there is a function. So this is x is equal to a and it is x is equal to b. Now we have to check whether it should be a differentiable. Differentiable means what? There should exist a tangent, and everywhere tangent, there should exist a tangent at each and every point in the closed interval AB. Okay, now. So to define differentiability, the first thing should be, f should be continuous in the closed interval AB. First thing, f should be continuous in the closed interval AB. Here closed interval AB. Then f should be differentiable at each and every point in the open interval AB. That should be there. F should be differentiable at each and every point in the open interval AB. So some others, they say that at A and B, that means here no need of differentiable at A and B. In some textbooks you see that there they put a closed bracket also. But in some, they say that open bracket A comma B. That means even though it is open bracket AB, there is no need of differentiable. Why? Because at the end points, so here at end points, there may be a chance of differentiable, non-differentiable. That means you cannot draw a tangent here, you cannot draw a tangent here. Why? Because there may be a chance of there may be a chance of non-differentiability may takes place here from this point. Then that's why they have taken this open interval. Open interval. You have taken open interval. That means here should be continuous. The function should be continuous. Here also should be continuous. This is A and it is B. X is equal to A, X is equal to B. At the end points, X is equal to A. At the end point, X is equal to B. The function continuous. Of course, total it should be also be continuous. And it should be differentiable at each and every point of in this interval. Okay, na? Then only the function is differentiable in the certain closed interval AB. That means we have to check each and every point that is differentiable or not. Of course, for that there is a general proofs are there that we will see that. Okay, na? So basing on this, what we are learned today, now I am going to explain a few problems that are very, very important for your JEE mains examination. Also, they are also useful for your JEE advanced also. Okay, na? So let us see the problems. Welcome to first problem. So we are going to check, there are certain functions are there. We are going to check the differentiability of those functions at a point x is equal to 5 by 2. What is the meaning of this? Means we have to check is there any tangent exist at the point x is equal to 5 by 2. Let us check that. So before doing this problem, f of x is equal to 2x minus 5, 3 by 5, whole power 3 by 5. First of all, we have to check, is it continuous at x is equal to 5 by 2. So that is a very easily, clearly we can do that. This problem is, so our main left hand side limit and right hand side limit both exist and they are equal. Therefore, it is a continuous at x is equal to pi by 2. So in the previous class, I explained how to check whether the function is continuous or not. Let us do that problem. Okay. So just to find out, the limit extends to pi by 2. So limit extends to 5 by 2. So 2x minus 5 whole to the power of 3 by 5 values you find out. So this is equal to 0. At x is equal to 5 by 2 value also, at x is equal to 5 by 2 also, f of x is equal to 0. That is equal to f of x, f of 0. That means limit extends to a f of x is equal to f of a. Therefore, the function is clearly a continuous function at x is equal to pi by 2. So, our main focus is whether it is a differentiable or not. For that, we will check the left hand side derivative and right hand side derivative. So, let us see that first you can find out the one derivative. So, that is equal to f dash of, here a is mod, this is a, that is equal to 5 by 2, that is equal to limit h tends to 0, f of 5 by 2 plus h minus f of pi 5 by 2, that is equal to h. This is equal to limit h tends to 0, f of 5 upon 2 plus h. This is equal to how much? Wherever x is there, substitute 5 by 2 plus h. That is equal to 2 into 5 by 2 plus h minus 5. 2 times in place of x, I have substituted 5 by 2 plus h minus 5 whole to the power of 3 by 5 minus. Clearly, no need to check f of 5 by 2. f of 5 by 2 value is 0. 5 by 2. 2 will cancel. 5 minus 5, 0. So, this is 0 whole divided by h. Now, let us see the what happens here. Okay, now. So this is equal to limit h tends to 0. So, you multiply 2 inside, 2 will get cancelled. Here 5 will come, plus 5 minus 5 is also get cancelled. So, this is equal to 2h whole to the power of 3 by 5 divided by h. Okay, now, right. Now, 2 to the power of 3 by 5, constant will come outside, 2 to the power of 3 by 5. Limit h tends to 0, h to the power of 3 by 5 by h to the power of 1. And this will give to 2 to the power of 3 by 5. Limit h tends to 0, this is 1 upon how much? 1 minus 3 by 5. That means h to the power of 2 by 3. See the situation. As h tends to 0, 1 upon h to the power of t by 3 tends to infinity. It tends to infinity. That means total function is tends to infinity. That is right hand side derivative I have find out, right hand side derivative or left hand side derivative, whatever may be that, both you will get that as h value tends to 0 plus or h tends to 0 minus, whatever may be that value tends to infinity. That means what? For this curve, whatever may be that curve, the shape of that curve 2x minus 5 whole to the power of 3 by 5, you will get a vertical tangent at x is equal to 5 by 2. You will get a vertical tangent, already I told, but x is equal to 5 by 2, since the function limit is tending to infinity, you will get a vertical tangent. Therefore, it is not differentiable. That means at x is equal to 5 by 2, you cannot draw a tangent, but there exists a vertical tangent. Understand this? Okay, I hope that you understand this problem. Let us go for next problem. Welcome to this problem. Discuss the differentiability of the function f of x is equal to sin x square upon x when x is not equal to 0 and it is equal to 0 when x is equal to 0. The function is equal to 0 when x is equal to 0. At x is equal to 0. At x is equal to 0. That means at x is equal to a, that value is 0. So, your a value is 0. At a is equal to 0, we have to check whether the function is differentiable or not. Before that, we have to check the function is continuous at x is equal to 0 or not. So, first point is checking the continuity of this function, at x is equal to 0. Continuity of this function at x is equal to 0. For that, what you have to find out? Limit x tends to 0, f of x value you have to find out. Let us find out this. So, limit x tends to 0, f of x when x is not equal to 0, x approaches to 0, when x is not equal to 0. For both left hand side and right hand side, same definition. That is equal to sin x square upon x. Now, what I am going to do is multiply and divide with x, here x square. We know that limit extends to 0, sin x square by x square, sin x square upon x square value is equal to 1 into limit extends to 0 of x value is equal to how much? 0. That is equal to 0 into 0 is equal to 0. That is f of 0. So, limit extends to 0, f of x is equal to f of 0. Therefore, by the definition of continuity, f is continuous at x is equal to 0, right. The first step what we have did is we checked whether x is equal to 0, the function is continuous or not. Yes, it is continuous. Now, we are going to check is there any tangent exist there or not. For that, so we have to do the differentiability of that function. So, for that right hand side derivative, left hand side derivative. Let us see the right hand side derivative. We know the formula f dash of a plus is equal to limit h tends to 0 f of a plus h minus f of a by h. So, directly I am writing the formula f dash of here. A means what here? 0, 0 plus. 0 plus is equal to limit h tends to 0 f of a means 0, 0 plus h, that is f of h minus f of 0 by h. So, what is this value? Limit h tends to 0. F of h means what? F of h means what? This is equal to sin h square by h minus f of 0. When x is equal to 0, f of x is equal to 0. That means it is 0. Whole divided by h is there. Whole divided h is there. Now, what is this answer for this? Limit h tends to 0, sin h square upon h square, this value is equal to 1. Therefore, the right hand side derivative, value is equal to how much? 1. Let us check the left hand side derivative. So, let us check here left hand side derivative. That is f dash of 0 minus limit h tends to 0. See here f of a minus h, a is 0, f of minus h. F of minus h means what? Sin of minus h whole square. Minus h whole square means h square only divided by x value is how much? Minus h into whole divided by minus h. Whole divided by again minus h is there, minus h. Minus f of 0 is 0, f of 0 is 0. So, this is equal to, so I am writing here limit h tends to 0 sin h square upon minus h into minus h, h square. This is equal to 1. So, limit h tends to 0 sin h square upon h square value is also 1. So, that is right hand side derivative value, right hand side derivative value is 1, left hand side derivative value is also 1. So, LHD is equal to RHD, therefore, the function is differentiable at x is equal to 0, therefore, we can draw a tangent at the point x is equal to 0. Understand this? So, first what I checked the continuity of that function at x is equal to 0. Afterwards, right hand side derivative and left hand side derivative I have found out. Both are equal, therefore, the function is continuous, differentiable at x is equal to 0. That means we can draw the tangent at x is equal to 0 for that curve. Okay, I hope that you understand this solution. Let us go for next problem. Discuss the differentiability of f of x is equal to under square root of 1 minus under square root of 1 minus x square at x is equal to 0. So, first try to understand the problem. What is meant by differentiability means what? Whether we can draw a tangent at the point x is equal to 0 or not. That means, if it is the curve, or we are able to draw a tangent at x is equal to 0. That means, here can we draw a curve or not? That is the thing that we are going to check. Understand it or not? Let us see that to check whether the given function is differentiable or not, we have to check whether it is a right hand side derivative and left hand side derivative at that point. So, that both should exist and both should be equal, then only we can draw a tangent at the point x is equal to a. Okay, now first those are the formulas that already we have. Let us check the right hand side derivative RHD. So that is limit. So this is called as f dash of a plus. A means what? X is equal to a. So here 0 plus. So that is equal to limit h tends to 0 f of a plus h, that is 0 plus h minus f of 0 by h. So that is equal to limit h tends to 0 f of h minus f of 0 by h. So that is a limit h tends to 0. F of h means what? So root of 1 minus root of 1 minus h square minus f of 0, wherever x is there substitute 0, this is 0, 1 minus 0 1, root 1 1, 1 minus 1 1, root 1 0 upon h. Okay now. So let us find out this value, limit h tends to 0 root of 1 minus root of 1 minus h square. So you can remove this minus 0 here, so that is equal to, take the multiply the numerator and denominator with root of 1 plus 1 minus h square upon root of 1 plus root of 1 minus h square. Okay now. So this is equal to limit h tends to 0. So this is a root, okay. So in the inside the root, a plus b into a minus b, a square minus b square. A square means 1 minus b square means this root will go 1 minus h square, plus 1 minus 1 will get cancelled, plus of minus 1 cancel, root of h square upon h into root of 1 plus root of 1 minus h square. So root of h square is equal to modulus of h. This is mod h by h into root of. This we can take it away because h tends to 0, 1 minus 0 square, that is 1, 1 plus 1 root 2 you can write down. Now coming to here, h tends to 0. What is 0 here? 0 plus. 0 plus means what? X greater than 0. X greater than 0. That means, h greater than 0. Okay, now h value here greater than 0. We are approaching 0 from right side. Okay, therefore modulus of h will become h. This is equal to h by h root 2. These 2 will get cancelled, 1 by root 2. So what is your right hand side derivative? 1 by root 2. So the left hand side derivative also, if you proceed in the further way, so here h tends to 0 minus. H tends to 0 minus. That means what? Modulus of h will become, so your left hand side derivative is limit h tends to 0, modulus of h minus means h by root 2. This is a minus h by h root 2. h will cancel, minus 1 by root 2 you will get. So right hand side derivative is plus 1 by root 2, left hand side derivative is minus 1 by root 2. Therefore, LHD is not equal to RHD. So at the point x is equal to 0, its left hand side derivative and right hand side derivative. The left hand side derivative is 1 by root 2, the right hand side derivative is plus 1 by root 2, left hand side derivative is minus 1 by root 2. Both are not equal. Therefore, we are unable to draw a tangent at the point x is equal to 0. That is not, at x is equal to 0, the function is not differentiable. So that is the final answer for this. Okay, now? Right. I hope that you understand this solution. So let us go for next problem. If we don't know the definition of branch functions, I have already given sin inverse of 2x upon 1 plus x square is equal to 2 tan inverse of x if x lies between minus 1 less than or equal to x less than or equal to 1. So that is pi minus 2 tan inverse of x if x greater than 1. So this is minus 5 minus pi minus 2 tan inverse of x if it is x less than minus 1. Such branch wise the definition is given. Generally, if we don't know the definition, generally students, majority of the students is unable to remember such a type of branch wise definition. Sir, how to proceed in a general way, sir? Let us see the general procedure. So general procedure means what? First to find out the derivative of this function. Let us see what happens. So what is the derivative of this function? F dash of x is equal to sin inverse of x derivative. Sin inverse of x derivative means what? 1 upon root of 1 minus x square. That means 2x upon 1 plus x square whole square into the derivative of 2x upon 1 plus x square, u by v formula, that is v into derivative of 2x is equal to 2 minus 2x into the derivative of 1 plus x square is 2x whole divided by 1 plus x square whole square. Okay, now, so let us simplify this thing. So this is equal to 1 root of 1 square. So this will become, if you take this LCM, so this is equal to 1 plus x square whole square minus 4x square by 1 plus x square whole square. So this is equal to 2 into 1, 2. So this is a 2x square minus 4x square. 2x square minus 4x square means minus 2x square, that is equal to 1 minus x square. You can write down 2 into 1, 2. So this is 2x square minus 4x square minus 2x square upon 1 plus x square whole square. Okay, now, so coming to here, see here, 1 plus x square whole square minus 4x square, that is a plus b whole square minus 4ab. So what it will come? A minus b whole square. So ultimately, so this is square root of 1 plus x square upon 1 minus x square whole square into 2 times 1 minus x square by 1 plus x square whole square. Okay, now, so I have taken 1 by, I have taken 1 plus x square in the denominator, 1 minus x square. Now this is nothing but your modulus of 1 plus x square upon 1 minus x square into 2 times 1 minus x square by 1 plus x square whole square. So if you see here, 1 plus x square, it is always a positive quantity. 1 plus x square is a always positive quantity. Why? Because x square is always positive, 1 is also positive, positive plus positive is positive. So this is equal to 1 plus x square upon modulus of 1 minus x square into 2 times 1 minus x square upon 1 plus x square whole square. Okay. So here modulus of 1 minus x square, we don't know that depending upon x value, that may be positive, may be negative. That's why I put modulus there. So any more cancellations? Yes, 1 times will be cancelled. Ultimately 2 times 1 minus x square upon. So this is equal to 1 plus x square into modulus of 1 minus x square. So this is your f dash of x. What I did know, whatever may be the given function, I have find out the derivative of that function. So here be careful as you are a IIT students, those who preparing for IIT JEE mains examination. So don't, generally students will do like that. They will start doing cancel, they will cancel like that. Don't do that. So why? Because we have the property root of x square is equal to mod x, root x whole square is equal to x. Okay, now, right. So we got here modulus. Now I am going to see here, I am going to check the differentiability of this function at x is equal to 1. At x is equal to 1. That is equal to f dash of 1 plus 2 times 1 minus x square upon 1 plus x square by, see here, 1 plus means what? 1 plus means we are approaching the values which are greater than 1. Greater than 1, you take any one value, So for example, 3 by 2, 1.5. So if you put here 3 by 2, this is a 9 by 4. So 1 minus x square, 1 minus 9 by 4. So therefore it will become a negative. 1 minus x square is negative. Then the modulus of negative will become this x square minus 1. Understand this? X square minus 1. So if you substitute here x is equal to 1, 1 plus 1 gets cancelled. Sorry, 1 plus 1, 2, 2 will get cancelled. This is 1 minus x square, this is x square minus 1. These two also will get cancelled, you will get minus 1. What is the right hand side derivative? You are getting minus 1. What is the left hand side derivative? That is 1 minus is equal to, so 2 into 1 minus x square by 1 plus x square into, now what about 1 minus x square value? X is less than 1. Less than 1 means take any one value, for example 1 by 2. So this is 1 minus 1 by 4. 4 ones are, so this is 3 by 4. It is greater than 0, this is less than 0. So here 1 minus x square is positive. That means you will get 1 minus x square only. This you will get cancelled, you are getting 1. That means what? So here at x is equal to 1, the right hand side derivative is -1 at x is equal to at x is equal to 1, the left hand side derivative is equal to 1. Both derivatives are not equal, therefore, the function is not differentiable at x is equal to 1. Understand this? Like this also you can approach, but you have to be careful that you have to write the modulus symbol here. So, if you don't write the modulus symbol, almost both will get the same answers. The conclusion will leads to it is differentiable at x is equal to 1. Okay, now I hope that you understand this solution. So, dear students, I hope that you enjoyed today's class with some more problems and some more concepts, and tomorrow's class I will stand before you. Until then, all the best.